is 4.3, and yes, we're choosing values, video 4.3 for 8th grade math. We're choosing and graphing linear equations, choosing the x value. The graph of a linear equation is a straight line. Only 2 points are needed to graph a line. However, we will graph 3 points to check for accuracy, just to make sure we haven't made any kind of mathematical error when we're solving for y, putting in an x. Steps to graph a linear equation. You're going to select 3 values for x, and I'm going to put a stipulation there. I would like you to choose a negative value, a positive value, and a 0. So I would like you to choose a negative value for x, a positive, and 0. I'll show you what that means. Substitute these values for x into the given equation that you're given that you have to solve. Solve for y. Write the values in the xy table, graph the ordered pairs, draw a line through those points, label a line with the given equation. So we've done all of that part there. We've written the values or figured out the tables, graphed the ordered pairs, drew the line, and labeled them. We've practiced that. So we're adding on the new piece of just choosing the values for x. Graph each of the linear equations below on the same coordinate plane. So I'm going to put 1, 2, and 3 all onto this coordinate axis here. So I get to choose a negative value, -4, 0, and a positive value. So I'm choosing -4, 0, and 4. I want to stay close to the origin. I don't want to choose -20, 0, and +32. You want to choose values usually between -3 to +3, -4 to +4. You don't really want to go a whole lot bigger than that. So -4 gives me -4 minus 4. When I put this x into this equation, -4 minus 4 gives me -8. 0 minus 4 gives me -4. 4 minus 4 gives me 0. I'm going to solve all the tables first. The graph number 2, y equals 3x minus 1. Well, I'm going to choose -2, 0, and +2. -2 times 3 is -6, minus 1 is -7. 3 times 0 minus 1 is -1. 2 times 3 is 6, minus 1 is 5. And number 3, y equals -2x plus 3. Ooh, I know it's going to be a negatively sloping line going through the y-axis at +3. So I know you already know y equals mx plus b form. That's the function slope intercept form of an equation. So I know this is going to be a negatively sloping line. -2 times 2 gives me -4 plus, gives me +4 plus 3 is 7. -2 times 0 is 0 plus 3 is 3. 2 times 2, -2 times -2 is -4 plus 3 is -1. So now I'm going to graph these points. Number 1, -4, -8. -4, -8. 0, -4, and 4, 0. Interestingly, I have graphed both the x-intercept and the y-intercept. We know the y-intercept. Now I'm carefully pretending I'm lining up my ruler here, sighting out up 1 and over 1, because I know my slope is up 1 for y, my rise over my run, down over 1 for x, up 1, over 1. So I'm very carefully, make sure you have a very sharp pencil when you're doing this, and I'm graphing this line, and I have both my y-intercept here at 0, -4, but I also have my x-intercept, 4, 0. This is the y-intercept, and this is my x-intercept. We haven't talked about that, but where does the graph cross the x-axis? God, I can't talk today. So the equation is y equals x minus 4. And I don't want to label it too close to all of my numbers here, the Cartesian plane numbering. So I'm going to label off to the side there. Y equals x minus 4. Number 2, 3x minus 1. So -2, -7. And 0, -1. And 2, -5. Oh, -2, -7. Oh, and 2, 5. Wow, that's not right. That wouldn't work. 2, 5 works. Yes, wrong answer up there. 2, 5. Wrong sign on that. those are going up in a line. So please do make sure that they go in a line. If they don't, if you get a zigzag, you've done something wrong. So here's my point. I know my slope here is up 3 and over 1. So I'm going to cite up 3 and over 1 just to extend my line a little bit there. And this is number 2. 3x minus 1 equals y. I'm going to label it with the original given equation. And the last equation here, negative 2, 7. So negative 2, 7. And 0, 3. And 2, negative 1. So connecting that, I know my slope is down 2 and over 1. So down 2 and over 1 would hit there, down 2 and over 1 would hit there, down 2 and over 1 would hit there. So arrows on both ends of the line that you're drawing, and I'm going to label this equation y equals negative 2x. Make sure I can read it, negative 2x plus 3. So we've got 3 lines on one Cartesian plane. Let's go over to the back side. Talked about this in class. You want to have nice integral answers. Oh, my line isn't going to work here because this paper's a little not very straight. It's not oriented very straight. Let's see if I can draw an axis here first. So this is the y-axis. Take a moment. Put the x and the y-axis on your graph paper using a ruler. Using a ruler, please. Always using a ruler. We want to be accurate. Graph each of the linear equations below on the same coordinate plane. I talked about this in class, how when you have 1/3 x, that's another way I could write this as 1/3 x minus 1. So when I choose values for x, I want to choose values that are going to give me whole numbers or that are going to clear that rational. So I'm going to choose negative 3, 0, and positive 3. Or I could have chosen negative 6, 0, and positive 6. Negative 3 times 1/3 is negative 1 minus 1 more is going to give me negative 2. 0 times 1/3 is 0 minus 1 will give me negative 1. 3 times 1/3 will give me 1. 1 minus 1 is 0. So again, I have on this graph number 4, I have both my y-intercept, 0, negative 1, and my x-intercept, 3, 0. And I also have the point negative 3, negative 2. And I'm just going to take a moment here and number my axes. And I like to number 4 in all directions so I can establish the pattern that yes, each box or each line on the graph paper represents one unit. And I'm going to use my ruler tool, and I'm going to connect carefully my 3 points and extend my line through the graph paper that I have here. And that equation is y equals x/3 minus 1. The next equation, 3x minus 1 equals y. I'm going to leave this one for you to do. Do number 5 on your own. Put it on the graph paper. We'll talk about that tomorrow. So I'm going to go on to number 6. You can pause the video and do number 5 and then come on to number 6. Number 6 is written in standard form. Slope-intercept form, which is also function form, you could solve this also as y equals negative x plus 6. I know this is going to be a negative sloping line through the y-intercept of 0, 6. I like to choose the intercept, the y-intercept, is one of my values. That's why I choose 0 for x. I know it's going to be 0, 6, because when I put 0 into this equation for x, plus 6 has to equal 6. So 0 plus 6 has to equal, y has to be 6. If I choose, for instance, negative 3, then I put it into that equation. Well, the opposite of negative 3, and I'm using this form right here, the opposite of negative 3 would be 3. 3 plus 6 would give me 9, would be the y value coordinating with that. And my last value that I'm going to use is 3. Well, 3 plus 3 equals 6. So I used this form of the equation to solve. So negative 3, 9, that's way up there. good thing I got that on there. What happens if you run out of graph paper? Say you put your x-axis up a little too high, and you can't plot -3, 9 up there. No, 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 no. Can't go off the graph paper. So then you would have to come over to your table and maybe choose -2 instead. -2 would give me 8. Maybe your graph paper does go up to 8, but it doesn't go up to 9. So whatever's in your table has to be on your graph. Cannot go off the graph paper. You can't just like hand sketch in and put more graph paper up here. No, 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 no. Okay, don't do that. You have to fit your values on the graph paper that you're given. So, the -3, 9, 0, 6, and the 0.33. Oh, look at that. It intersects. It has a common point, a common solution with my other equation. They have a point or a solution in common. No, they don't. 3, 3, silly. Oh, not 3, 0. 3, 3. No wonder that wasn't lining up. Did you see that? It's not going to go in a straight line. You did something wrong. So yes, it did something wrong. I said 3. I have 3, 3 on the table, but I said 3, 0 when I went to graph them. Here they are lining up. Oh, they do have a point in common, but it's not a nice, easy to read point. It's where these two lines intersect right there. Oh. So my equation that I'm going to write on this line is x plus y equals 6, the original given equation. You should also have line 5 on there as well. Special cases on the bottom. When the equation contains only one variable. So I'm going to have either 0 slope or no slope, and they're going to either be parallel to the x-axis or parallel to the y-axis. Y equals 3. Well, I go to build my table, and I choose my 3 values for x. -2, 0, and 2. Well, every time y is 3. I don't have a choice, because this really is the equation y equals 0x plus 3. Well, 0 times -2 is going to give me 0 plus 3 will give me 3. 0 times 0, 0 plus 3 will give me 3. 2 times 0 will give me 0 plus 3 will give me 3. Y is always going to be 3. Might as well just fill it in. I really didn't need to solve that. So -2, 3, 0, 3, and 2, 3. Those are my 3 points. And I'm going to use a ruler very carefully in drawing this horizontal line that has a slope of 0. We saw that. The slope is 0 on a horizontal line. And this is the equation y equals 3. X equals -1. Well, I don't have a choice for x here. I have to put in -1, -1, and -1. Well, what's my y values? Choose 3 y's. Oh, okay. 2, 0, and -2. So -1, -2, -1, -2, -1, 0, and -1, +2. Yes, they are lining up. They are lining up parallel to the y-axis here, because yes, graphs that are not functions are x equals lines, x equals -1, and they have no slope. So that is the line x equals -1. Number 9 is going to look very similar to that because it's an x equals, but oh, no, it's not. So I have to make it an x equals. Dividing by 5 on both sides, I get x equals -2. So no choice for x here. Choose 3 values for y. -2, -2, -2. So I'm going to choose -2, 0, and +2 for my y's. -2, -2. That's this point. -2, 0. The x-intercept. And -2, 2. So yes, this is the line x equals -2. And I'm going to label it 5x equals -2. Why am I labeling it 5x equals, I'm sorry, -10? Because you have to label the line with the original given equation, 5x minus 10, not x equals -2. Yes, it is the line x equals -2 in simplest form. Dividing by 2 on both sides here, I get y equals -4. No choice on my y values, -4, -4, -4, -1, 0, and +1 for my x values. So I have -1, -4, 0, -4, and 1, -4. So that line is also a zero-sloped horizontal line parallel to the x-axis, which is the line y equals -4. And that's it for today.